Thank you for joining I Am Possible, which is India's first future tech meets sustainability podcast. And today I'm delighted and honored to have with me a young and dynamic entrepreneur who intends to change the world by building affordable, open source, and innovative hardware and software solutions. He is a biotechnologist with a passion for electronics and computer science and the founder of Upside Down Labs, which is building biopotential amplifiers, devices that can record EEG, ECG, EMG, and EKG signals. So, Deepak, welcome to the show. And what you are doing is going to enable healthcare and so many other dimensions. So, what is it that you are doing at Upside Down Labs, and what is the problem that you are solving?
Okay, so we at Upside Down Labs create affordable open source hardware and software projects, basically solutions to help users amplify their efforts and rectify their pathway to success. And our logo signifies that also. It has an amplifier and a rectifier, which is also known as a diode. Uh, we have made a mark in the Made in India DIY neuroscience sector with our competitive yet affordable neuroscience kits that come in an easy to use form factor, allowing neuroscience enthusiasts to record and visualize biopotential signals like ECG, EMG, EOG, and EEG, and create their own brain computer interface and human computer interface, whatever you call those devices that takes signals from your body and helps you control the digital things in digital world. We are also working on a platform for the development of novel prosthetics and human augmentation technology for revolutionizing the way amputees interact with the world. So, in addition to all of that, Upside Down Labs provides custom technology development services to various companies. Currently, we have 5 clients for whom we are developing custom technology in the domain of DIY electronics, prosthetics, and physiology sensors.
So first of all, I think let's explain what open source is to my listeners, and then maybe you can get into these customers of yours. You mentioned there's 5 customers. What are the products that they built with these 5 companies that you're talking about?
So, by open source, we mean that everything we do is open to you. If you want to create some product like what we are building, you have the files, you have the schematics. You can just take the files, create the Gerbers, send it for manufacturing. You can even create your own workshops, take our design, create your own workshops. You don't have to even ask us if you can do that. It is available for free and open to everyone. Even our graphics are open source, so you can use graphics in your uh, whatever you are trying to build for somebody to teach neuroscience. You can use our hardware and even our software. So that is what we mean by open source. And I forgot to mention that we are the first company in India to introduce neuroscience kits and DIY neuroscience equipments to students, researchers, and hobbyists. The company which are in contact with us, for whom we are developing the hardware, they are building prosthetics. One company of Karnataka is building prosthetic hand, affordable prosthetic hand. We are helping them to create a prosthetic hand that they can sell for less than 2.5 lakh rupees. A prosthetic hand of that kind can cost up to 25 lakhs to 50 lakh rupees. So we are cutting the cost by a huge margin, and the technology in the hand, the entire electronics is designed by us. Beside that, we have 2 companies who are into STEAM, so science, technology, engineering, arts, and maths. So we are helping them to create their own uh, DIY electronics kits so that they can teach students even at the age of, let's say, 8, at the grade of even 5. You can teach them electronics with easy plug and play solution. So we are helping them to build those kind of technology, where we are having collaboration with a company who is building invasive technology. So Upside Down Labs has started developing the technology that we will take forward with our another company. So it's a close project right now, but we are into invasive technology also. A lot of companies are building something cool. Not all of them have the sensor they require for creating those kind of real world products. They are sourcing them from USA, China, but so we can develop those hardware here in India itself, and we can supply them the novel, innovative sensors they require for their real world application types of products like prosthetic hands.
Lovely. How cool is that, Deepak? I mean, you are saying that you're not just building a product, but you're completely open sourcing it and giving it to everyone. Normally, when you build a product, most of these companies, they patent it so that they can keep on monetizing it and juicing it till forever. But here is an entrepreneur and a team, Upside Down Labs, which is saying that you have built India's first do-it-yourself neuroscience kits and tools, and you are giving it obviously as cheap as possible. You're kind of democratizing and redefining how we can read information from a body and build products, right? So let's talk about the first company. You said there's this company that you're working with, Hyderabad, who's building a prosthetic limb, right, leveraging your kit. And you also mentioned that you have done the entire back end. So would you like to explain a little talk about this prosthetic limbs? Because there are companies in the US who are talking about, and in fact, NASA is working on a prosthetic limb which is going to be connected to the brain. So it's a prosthetic limb. So you will be able to finally, he will be able to touch and feel the world like a normal man. So these are fantastic things happening, but and these are very, very costly. So you said that these prosthetic limbs, which cost somewhere around 25 lakhs or upwards, with your technology you can cut down the price to almost 2.5 lakhs, right? So this is really, really interesting. So break this down from our audience. Describe about the prosthetic limbs and the process and this collaboration with this company that you're talking about.
Either you have some disability from birth, or you get the arm or your leg amputated afterwards. When doctors amputate your, let's say, hand, you have those nerves that controls your fingers and control your entire arm. So basically what we are doing, we are using a novel biophysiological sensor, bioelectronic sensor, to take those signals, digitize them, send them to some microcontroller or the brain of the prosthetic hand that will control all the motors. Those motors are connected to your fingers and thumbs. So when you send a signal, let's say you want to move your thumb and you are thinking about moving your thumb, you are sending the signal, but you don't have the entire hand, so it doesn't go after this part of your body. So we just connect the electrodes to wherever we can find the nerves. When you want to move your thumb, you send the signal. We basically sends those signals, digitize them. We have some algorithms that will detect you want to move your fingers or your thumb, and we send those signals to the motors. And basically this is how your uh, prosthetic hand works in simple words.
I would want you to break this down a little further, because you said that this is the amplifier, bioamplifier tool that you have, and you put these electrodes on the hand. So for an example, let's take a man who's been amputated and his arm is not there. So you have your bioamplifier product, and these electrodes are fit onto the hand, and it reads the nerves, the whatever the parts, the nerve signals, and you have an algorithm which understands that, okay, this person wants to move his finger, and then it conveys the signal to the prosthetic limb, and the prosthetic limbs does the function, right? That's the way, right? So but how does this work? So you are partnering with this Hyderabad company. They have built this prosthetic arm. Is it something that will there be like a something that the person will need to carry with the prosthetic limb, or everything is attached inside the prosthetic limb? How does this work? Can you explain this?
So you have different options to connect the biopotential amplifier to the body. Either you use electrodes like this. These
Okay.
are gel electrodes. It just contains you can say salty water, which is converted into a gel. We put that below this electrode stud, and we record the signals. This is one way of doing this. We use this type of electrode for ECG basically, but for a prosthetic hand, where we want the prosthetic limb to be connected all the time, we use dry electrodes. So they don't have this kind of gel. Uh, they are a bit noise prone, but definitely very comfortable than using this kind of electrodes. So that is the part that connects to your body directly. Then we have wires coming out of those electrodes, either gel or dry electrodes. Those wires connect to the biopotential amplifiers. The biopotential amplifier is basically a cascade of amplifiers that has very very high CMMRR, common mode rejection ratio. So you have two electrodes that connect to your muscle and one reference that connect to any part of your body. So those two electrodes take the signal. If the signal is similar on both electrodes, the amplifier can reject those signals at a high margin. So basically, if you have a potential that will be recorded, if you have a similar signal, like if I connect the biopotential amplifier right now, there are a lot of signal in this room,
Exactly,
let's say
exactly.
50.
Right.
So if that signal is recorded, that signal will be recorded by both of the electrodes and with same amplitude. So it will be rejected. And if the signal is coming out of the body, it will be a potential difference that the biopotential amplifier can record very easily and with a high accuracy. So we record that signal, the analog signal, then we send it to the ADC, analog to digital converter of our computer or our MCU, microcontroller unit. Uh, those signal will be converted into digital signals. Let's say you have a 10-bit or 12-bit ADC. For 10-bit ADC, you get the value of 0 to 1024 at max, 2 to the power 10. Or for 12-bit, you get 0 to 4096. These are some of the ADCs that are used in prosthetic limbs a lot. If you get that kind of signal, you can basically say that the muscle you are recording is giving out a specific amplitude of signal. So that amplitude can be used to signify that if somebody wants to move their thumb or move their hands, if you want to move your thumb, you will send a signal. Signal will be of some amplitude, and if you get a signal above, let's say 200, you say the person wants to move their things like that. The signal will be sent to the motors.
What's the algorithm behind it? You know, you guys are building the hardware. Is the algorithm is also being done at your end? And when does this product come to the market?
Okay, there are two types of algorithm we use in prosthetic hands. One is a closed black box. We design with machine learning and artificial intelligence. We train the algorithm to detect the signal and infer the signal, infer the mode of operation for that prosthetic hand. Let's say if the signal is coming in and the person wants to uh, wide open their hand, the signal will be classified the algorithm itself. But not, it is not for everybody, because you have to test and retrain the model every time you want to use with someone. The other type of algorithm is very simple, and let's say you have three muscles which you can record and classify, as in you can record without interference from the other muscle. So what you can do, if the person sends a signal to the muscle one, you say person wants to open their hand. If the person wants to close their hand, they send the signal to muscle 2. If the person wants to change their grip, person can send the signal to the muscle 3. So we just have to target those three muscles, and we need to get the signals, isolated signals. The signals will not be affected by each other. If we can record signals from this type of muscles, we can create a basic algorithm that can be understood by everybody, and it just opens, close, and change your grip pattern. So either you want to do this or do this can be changed by muscle 3, and open and close can be controlled by muscle 1 and 2.
Everything gets done in-house, the hardware and the software, everything is being done by upside
Yes.
down labs, or is it being outsourced by, you have other partners?
No, we don't have any other partners. We design the hardware ourselves, and we write the initial firmware for our clients. because we are mainly into hardware right now. So we give them the basic algorithm and basic firmware for the device. So when we ship the hardware, they have the program to control all the motors to get the signal from the amplifiers, and a basic algorithm, just like I told you, three muscle can be targeted, and those muscle can be used to either open, close, and change the grip pattern. If they want to use the hardware and implement their own machine learning and artificial intelligence type of algorithm onto the machine, they can definitely do that. But we are not supplying that right now.
These kind of products and these kind of tools, once it comes in the hand of everybody, and right now it's just a 3-member team, and it looks like Bhavna does the design and Dikshant does the marketing end, and both the hardware and the software is done by you only. And I think you more people joining in and helping in. I think there'll be so much that could be done, with the product that you're building. So tell me about this steam, the partners that you have, because you're saying that eventually these do it yourself electronic kits that you're selling and you're supplying, neuroscience kits, even 8-year-old kids will be able to use it. It's that simple, right? So tell me a little bit about that. And are you talking to schools, are you talking about to universities to kind of create partnerships where you can make them understand how these tools can be leveraged for STEM?
Yeah, definitely. So what we are building for them is a platform where everything is modularized, and you have basic modules for everything: power module, a feedback module, and control module. Feedback modules are those modules which can give you feedback in uh, terms of either sound, light, vibration, things like that. And then you have control modules that can sense the environment or can get the signal from you, as in you can press the button and it will turn on the feedback device. Those feedback devices can also detect your the presence of light. Those feedback modules can also take signal in terms of heat, things like that. Those are sensory modules and take feedback from you or the environment. Then we have power modules. These are basic modules like a battery, or you can use your power bank or your charger also to control the entire kit.
Deepak, talk a little bit more about your products and what are its possibilities. I mean, what else can be done? Because you're just opening up bits and pieces of what the possibilities of a product. Talk to me about the product, because I guess, I mean, there is so many products which could be built leveraging your bioamp, your biopotential amplifier, right? So what are the signals that it can currently read?
So if we talk about neuroscience, people think that everything that is related to brain is neuroscience, but it is a study of neurons and how the nervous system works. Anything and everything that is related to connected to your nervous system, we are developing sensors for that. So you can take signals from your muscles, that is EMG. You can take signals from your brain, that is EEG. EMG is electromyography, EEG is electroencephalography. If you are talking about your eye, those works in a very, like, they are great. You can take signals from your eyes, and even a person who is amputated, who is paralyzed, can use just their eyes to control things around them. It is marvelous. So the signals that are coming from eyes are called EOG, electrooculography. Then we have our heart. Those signals are ECG, electrocardiography. We are building sensor for all of those signals, and our sensor, our basic chip that we have released right now, and the bioimp chip can record all of them, and you don't have to change anything on the hardware. There are some things you have option to change everything. You have the option to change the filter. If you want to use 2 electrodes for the heart, if you want 3 electrodes for other potential biopotential signal, you can do that. And it is pretty small. So this is our bioimp example. It's pretty small, smaller than like comparable to a 2 rupee coin. The diameter of a 2 rupee coin, it's only 1 mm wide, and the height is 2.54 mm. So this can record all your biopotential signals, um, be it either your ECG, EMG, EOG, and EEG. So this is one of the hardware we are building. We also have Biome version 1.5 on our store. We launched our own store in December 2021. So anybody can buy products from our store. And we are going to release our new hardware. This is a muscle bioamp shield. Uh, so one thing I want to make clear, things we are doing right now are not basically new for India, new for uh, like new in terms of how we are building it, how we are designing the hardware, but it is first initiated and brought to the masses by Greg Gage of Backyard Brains. Backyard Brains is a company of USA, United States of America. They have shields and sensors like this. They don't have this kind of sensors, but they have this kind of shields. uh, Equipment that is used for neuroscience, teaching neuroscience, can cost up to 40,000 USD. So things that can be sold for 40 USD are can revolutionize the way we are learning and teaching neuroscience to kids. So definitely we are revolutionizing the second phase, second circle of this DIY neuroscience. Packard Brains already revolutionized that in USA, and they have shipped to a lot of countries. But we are going to make it even cheaper, even affordable, and we are going to ship to all the countries. We have already shipped to 10 plus countries right now, and we are building the products to reach even more countries. So this is our muscle biome shield. It records your EMG, basically signals coming out of your muscles. I have put one electrode on the backside of my hand. This is for reference, and I have two electrodes near the ulnar nerve. This nerve comes right here. This is one of the largest nerve in your hand and very easy to access. That's why I have put electrodes here. So I have connected the black electrodes for muscle recording here, and the reference red electrode here. When I connect the battery, starts, and you can see when I
Right.
flex my muscle, you can see the signals.
Yes.
That's not all for this shield. You can also listen to the signals using your 3.5 audio, uh, like these earphones. Basically, you can connect them here and record. uh, if you want to record, you can also record through this jack also, but we have provided another jack for that. You can listen to the muscles using this. Then we have one port for visualizing and recording the signals on your mobile or your smartphone. And that same cable can be used to send the signals to a Bluetooth speaker like this, and you can listen to the muscles. Let's see if we can do that right now. So you can see
Yes.
the LEDs are visualizing the strength of my muscles and how strong I am flexing. And the signal can also be, uh, you can hear the signals in this Bluetooth speaker.
I'm so excited with this product, because I mean, see, the possibilities of this is going to be endless, because endless for healthcare, endless for learning. You mentioned that these neuroscience kits which people are using, it's 45,000 odd, and what you are selling, what was the price that you mentioned for this new
40 USD.
40 USD? So how cool is that? I mean, we need entrepreneurs such as yourself who break the barrier of our current businesses, because our businesses have somehow always been squeezed out forever. I mean, when there are ways to create products at a minimum cost, and I think that's the only way we can democratize technology. Otherwise, technology has for the longest time been something which was accessible only for the rich people. There was these cool technologies, like you talk about brain computer interface, these prosthetic limbs. There is, I don't know the exact number of the people, but there's so many people in India who are amputees, and this could be just a ray of hope for those people, where you could democratize these products and make it accessible to everyone. So wish you and the team the very best, Deepak. And I mean, I will definitely do whatever from my end to kind of push this and make sure that it reaches the right people. You also mentioned in the beginning of the conversation that you are looking at now exploring invasive tech, because so far most of the companies, I mean, there are companies who are working on invasive as well as non-invasive tech, but it's when you go invasive you are able to actually understand and read those signals, like much better,
Definitely.
so first of all, maybe, just for my listeners, I mean, who do not understand the difference between invasive and non-invasive tech, maybe just explain that and then talk about what you're trying to do with invasive tech.
Yeah, definitely. So invasive in simple words is like invading something. So non-invasive is uh, th- this electrode is non-invasive. It is sitting on my skin. If I talk about invasive electrodes, those are needle-like electrodes that will go beneath my skin to record the same signal which I am recording right now, but with more accuracy. As in, the signal will be high and noise will be at a least amount in the signal. It will be attenuated. So the products we are building with the company, those no, invasive technology will only be used in your research institutes to take the signals out of your lab mouse, monkeys, uh, animals. Basically, those animals are used for learning about brain and things like that. So we are building very fine electrodes with the company, and we are developing the hardware for that fine electrode that can be used using a normal USB Type C cable that can be connected to your mobile phone or your computer to take out the signals. Those invasive electrodes and the acquisition system. Just talking about the electrodes, those electrodes can cost you around 1000 USD for a single electrode. What we are building, we are looking towards creating the entire system, the electrode and the acquisition system on a board, on a single system that will be very low cost, very low weight, and can be used in various applications, less than 1000 USD. The acquisition system that you have to purchase with other electrodes can cost up to 20,000 USD. So the entire system uh, normally goes around 1 lakh USD, and we are providing the same technology for less than 1000 USD. So even researchers who don't have access to those kind of equipments can now buy from us and do the research here in India itself. All the electrodes, all the acquisition system I am talking about are developed in Europe and USA. So there is no company in India that is doing this kind of stuff. So we will also be the first company in India to introduce invasive technology that can be used in research applications and things like that.
Staying on this subject, could you talk a little bit more about your partners? Who are you working with? When you say invasive tech, I mean, these electrodes you're building, would it be used for leveraging brain computer interface? What are the initial applications that you
Yeah,
might?
definitely. So it will be used for brain computer interface eventually in humans. So basically, what Neuralink is introducing in USA, the invasive technology that will be used in humans eventually. They are trying it on pigs and monkeys right now. So we are going to start with that. We are going to create invasive technology that will be used in mouse first, then in monkeys. And if things goes well, we can increase the number of channels of our device. Basically, we will start with 8 channels, then we go up to 16, 32 to 56. And Neuralink right now has 1024 channels and
Right.
above that. So it is very dense. The device they are creating can be used and can be used to take signals from a specific part of brain in 4K. If we are talking about the current technology, if we are at just a single pixel, they are seeing it in 4K. So definitely a great advantage for uh, those people who are involved with Neuralink and using that technology. But we don't have that kind of technology in India, and it's better to start with something than nothing. So we are going to introduce 8 channel device first, then we'll introduce uh, more complex and more dense devices later.
I'm full of pride that a team in India and just a three-member team are doing something which is so humongous, and you are uh, attempting a eight-channel electrode, to for this. Would you like to talk about your research partner? Who are you partnering with? And you mentioned that in the course of the conversation that your product has been selling to almost 10 countries. So talk to us about the partner that for the invasive tech, that who are the research partners, and talk to us about those products that which is sold in these 10 countries. Leveraging those products, who are the people, I mean the ones who have bought those products, what are the interesting applications they have built using your product?
Okay, so a lot of researchers and scientists have used our products, and they are looking after writing research papers also. People have created very unique and like very innovative projects. Uh, Let me share some of them with you.
Please.
One person created prosthetic hand. They used the design by Invasive, and they 3D printed the prosthetic hand. They used the sensor to control that prosthetic hand. Padmalya, who was also our intern, created a project which can detect your drowsiness. So you can place electrodes near your eyes, and if you're studying, if you're doing something, and you want that somebody should tell, or uh, like you want to detect you if you are drowsy, the machine can detect if you close the eyes, if you don't blink your eyes for a specific amount of time, it will detect that you are like drowsy. And one person created a machine that can sit on your head, take signals from your eyes, and detect if you are moving your eye on left side, right side, up or down. So a very innovative and very good example how the sensor can be used. So if you use the sensor called EOG signal recording, and basically you can create a system that detects your horizontal and vertical movement of the eye. You can basically create a fully fledged keyboard or a game controller, things like that. So possibilities are endless. All other projects are similar to those, controlling some kind of robot using muscle signals. You can detect your eye blinks, you can detect your heart rates using our already provided, already written examples for Arduino. So you just have to plug your Arduino to your computer, flash the program, connect the bioelectronic chip to your hardware, and you are good to go to detect your heartbeats, detect your eye blinks. You can get envelope of your muscle signal, things like that. So we
Lovely,
have already provided example software for everything,
lovely. Deepak,
and
what's
everything is open source.
so tell me, what's the roadmap ahead for Upside Down Labs?
Okay, let, I think I haven't introduced how Upside Down Lab started, how I got into this biophysiological signal recording, biopotential recording. So it all started in 2016 when I was a freshman at Netaji Subhas Institute of Technology and SIT here in New Delhi. So I wanted to create some project. Actually, I am into electronics since childhood. As far as I can remember, I was into electronics. I was taking parts out of circuit boards, going to scrap store just to buy parts. So people used to throw away the parts and sell them to scrap stores, and I used to buy the scrap back from scrap store and used simple screwdriver. I didn't had any soldering iron, so I used a normal screwdriver. And after school, uh, in like very hot summer day, I used to sit and take the electronics parts out of those PCBs, and I used to put them in my geometry box. So when other students had pencils, erasers, things like that, I had electronics part, capacitors, diodes, and transistor in my geometry box. So basically, I was into electronics since my childhood. Then I was introduced. with introduced to computer science in my school. Then I learned the basics and more about the computer science and programming languages in my college. In freshman, I started with some novel. I wanted to create some novel projects, then record your biopotential signal. I saw someone recording biopotential signal, and I wanted to do the same. There is a famous TED talk by Greg Gage where he records the signals from someone's arm and controls someone else's arm. That is still we haven't done, and I'd like to do it in next 3 months definitely. So in 2016, I started with the thinking process behind this biopotential amplification. Then in 2017, I presented an uh, basic prototype of an affordable biopotential amplification at a conference for makers in NSIT only. And after 2017, I was introduced how to create your own PCBs at home. So in 2018, I created my own PCBs. They sat on my desk for 6-7 months. Then in 2019, I created a Tindy store named Upside Labs. So I chose on the name Upside Labs. In 2020, I sold those two biopetition amplifiers, and they were my first customer from USA. That inspired me to create my own startup. So I graduated in the middle of pandemic in 2020, and in the end of 2020, I registered Upside Labs as a proprietorship. In 2021, I met my partners, Dikshant and Bhavna. Actually, we were friends from college itself. Then I did my own work. They had some other things going on. Uh, we got in touch in 2021, started my Upside Lab LLP. And in February 2021, we got our first B2B client. Things got pretty awesome after that. We released Biopic Chipple, did a successful crowdfunding campaign at Crowd Supply, and won some awards. And here we are developing some more hardware. So 2021 was awesome, but we didn't release a lot of hardware, which we are going to fix in 2022. So we'll start with this muscle biamp shield in February of 2022, and we'll release different hardwares for muscles, uh, eye, heart, and all the biopotential signal you can record with are innovative, and everything will be open source as well.
Lovely. Deepak, thank you for taking time and being part of the podcast. I really, really enjoyed the conversation. You are an inspiration. You said that your journey has been, when the school days where everybody was playing around with their pen and pencil, you were playing around with tools, and you have taken that passion and created a product which I think can upend India's health industry, because I'm assuming there's millions in India who are disabled, and it's not just the disabled. I mean, but there are so many other applications which can come out of this, and you are on a journey with a small but a great team. And I really wish and I hope that in the next few years, Upside Down Labs will be a name which will be known not just in India but globally, because I think you're doing something really, really excellent. I'm extremely awesome and privileged to have this conversation with you. I wish you the very best, and I hope the people who are listening, or if there's investors, supporters, please reach out to Deepak Khatri and his team. I will leave below the email so that you can reach out, because I think he's doing something which is really, really cool. So wish you and your team the very best. And to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, see you guys. Bye-bye. Thank you. Thank you, Deepak. Really appreciate this.